Hi there, it's nice having you in today's class. So in this class, we're going to be talking about computational thinking and block-based programming. What is computational thinking? Computational thinking is solving big problems in simple, easy steps. Now, a very good example of that is getting set for school. There are a whole number of activities you would have to go through before you get set for school. First step, you have to wake up. Next, you have to brush your teeth. Next, you have to bath and then breakfast. Then you're set for school. This same way is how computers solve our problems. When we give them big problems to solve, they break it into simple, easy steps. And then we have our solution. Now that is computational thinking. What is block-based programming? Block-based programming is the use of blocks of code in giving a set of instructions or programming. Why is it called block-based programming? Because it involves the use of blocks of code and not text. By the end of this lesson, you will know the meaning of computational thinking and how computational thinking is used to solve problems in computers. You will understand the four components of computational thinking. You will also know about block-based programming, its importance, and examples. Now, talking about computational thinking, we have earlier said that computational thinking is solving big problems in simple, easy steps. This method is used by both humans and computers in solving problems. There are four main components of computational thinking. They are 1. Decomposition, 2. Pattern recognition, 3. Abstraction, and 4. Algorithm thinking. We will be looking at each component in detail. The first component of computational thinking is decomposition, and decomposition involves breaking down big problems into smaller, more manageable parts. A very good example of this is when you are given dirty dishes to wash. First, you will have to separate the dirty dishes into smaller groups. Groups like pots on one side, plates on one side, cups on one side, and so on. This way, you have succeeded in using decomposition. The second component of computational thinking is pattern recognition. And pattern recognition involves identifying similar patterns in a problem. Using our previous example, after separating the dishes into smaller groups, the next thing would be to identify similar patterns among the dishes. For the plate, that would mean having the ceramics on one side and the plastic on another side, and so on. The third component of computational thinking is abstraction. And abstraction means identifying specific similarities and differences among similar problems to work towards a solution. Continuing with our previous example, this would mean deciding on which group of dishes to wash first and next. The fourth and final component of computational thinking is algorithm thinking. And this involves a step-by-step instruction for solving the problem. Still on our example, algorithm thinking here would mean step 1, separating the dishes into smaller groups. Step 2, identifying similar patterns in each group. And step 3, deciding on which group to wash first. In this course, we will be focusing on block-based programming. And block-based programming is the use of blocks of codes in programming or giving a set of instructions. The codes are shaped in blocks and can be clicked and dragged onto the scripting area. For the purpose of this course, we will be focusing on two main examples of block-based programming, which are Scratch and MakeCode. Some of the importance of block-based programming are: 1. It introduces young children to programming at an early age. 2. It is fun and encourages creativity. 3. It lessens the burden of using difficult programming languages. During the course of this lesson, we talked about computational thinking and defined it as solving big problems using simple, easy steps. We also talked about the four components of computational thinking, which are decomposition, pattern recognition, abstraction, and algorithm thinking. And we saw how we can solve problems using computational thinking. We further talked about block-based programming and defined it as using blocks of code to give a set of instructions to a computer. We talked about its importance and we saw different examples of block-based programming. Now we have come to the end of this class. I'll see you in the next one.